this video, we're going to look at a bit more on matrices. We're going to look at the determinants and the inverse of a matrix, and a little bit on how to solve equations using the inverse of a matrix. Okay. So bit of a new notation. If we see the brackets where it's like a vertical line or two vertical lines instead of a curly bracket, that means the determinant. Okay. And we're only going to look at the 2 by 2 determinants in AS. In second year, we'll do it for 3 by 3. And all you need to remember this, basically the determinant of a matrix is this calculation. So it's AD minus BC. So it's to do with these diagonals, okay? And if you wanted to find the inverse of a matrix, so say if we had like a 2 by 2 matrix, and I said, well, what's the inverse of this matrix? The calculation, again, that we need to remember this. So it's 1 over the determinant. So it would be 1 over AD minus BC. So we multiply the original matrix by this fraction, and we also have to actually adjust the elements in the original matrix. So if the original matrix was AD, basically the way I think about it is we swap this diagonal and this diagonal we make negative. Okay, so swap that diagonal, and for this diagonal, I don't want to give it arrows because you might think we're swapping. For that diagonal, we make negative. And for this diagonal, we swap. So let's try an example, okay? Say if we had the matrix A, which was 2 minus 1. 3, 1, and we want to find the inverse of A. Okay, well, we do 1 over the determinant, which is AD minus BC, so that would be 2 times 1 minus B times C, so that would be minus 3. And then the matrix itself, we'll swap these over. So that would be 1, 2, and we'll change the sign of these. We multiply them by minus 1, so that become plus 1. And that become minus 3. So what have we got? Minus minus is a plus, so we've got 1/5 of 1, 1, minus 3, 2. You can leave it like that. Obviously, you could, we know how to multiply matrices by a value. You could multiply inside and you get 1/5, 1/5, minus 3/5. And 2/5, but you may as well leave it outside as well as a multiple. There's nothing wrong with that. Okay, example 2. We've got the matrix which is 4 minus 6 minus 2, 3. First of all, let's find the determinant. So if we use that notation, that means just find the determinant of the matrix, and let's see what happens when we do that. So the determinant of the matrix would be AD minus BC, so we do 4 times 3 minus 6 times minus 2, and that gives 12 minus 12. Okay, so really important that we realise that if the determinant is equal to 0, we cannot find the inverse of this matrix. Like, this matrix basically does not have an inverse. Okay, so there's nothing. Remember how an inverse works? Like, if you, what's the inverse of squaring something? That would be square root, and like, what's the inverse of, or the opposite of multiplying by 2, dividing by 2. Matrices are a bit different, obviously. So like, if you wanted to like undo this, if B was an operation, we multiplied by this matrix, you wouldn't be able to undo that, because if you're trying to find the inverse of this, look at the formula, that'd be 1 divided by the determinant. So then you maybe start by going, all right, then B minus 1, inverse of B, 1 divided by 0, and then like, obviously you can't divide by 0 in mathematics, so we would then just say the inverse does not exist. And there's a special term that you want to highlight in your notes. We'd say that if the determinant of B is equal to 0, then B is a singular matrix. Okay, so if the determinant is equal to 0, then we call that a singular matrix. In other words, the inverse does not exist. Okay. Before we move on, actually, while we're thinking about the inverse matrices, you want to highlight an important point in your notes. Okay. So if you do A times A minus 1, so if you multiply a matrix by its inverse, you end up with the identity matrix. Okay, and it also works the other way around. So if you multiply by A and the inverse of A, you end up with the identity matrix. Okay. Basically, the way to think about this, the identity matrix is the one matrix that doesn't change anything. Like it leaves the say if you multiply. All right, let's say if I did. Let's not use letter A. If I did B times by the identity matrix, the answer would still be B. Like it wouldn't change. If I did the identity matrix times by B, I also end up with B. So like this identity matrix is like matrix speak for let's just leave stuff the same, let's not do anything. And like that's almost like the same as what's going on here. So if I multiplied by A and the inverse of A, they'd cancel each other out. And it'd be like, oh, let's not change anything. Okay, it's like multiplying by 2 and then dividing by 2. The inverse operations cancel each other out. So we're left with the identity matrix, which means nothing's changed. Okay.